I'm Timmy.
I'm Justin.
I'm Nathan.
And this is Three Old Tech Dudes.
Where in the world is Carmen Sandiego?
Texas. Bahamas.
Scan in Scandinavia. Wasn't that the line? Scan in
getting late.
Scandinavia.
I don't remember. I remember the little tune.
Hit it, Rockapella.
Rockapella.
All right. Well, I'll tell you what. I've been had the soldering iron out, playing with my tubes again.
You didn't burn yourself, did you?
Not this time.
Not again.
I had this old Philco in the garage, old plastic radio from the mid '60s. Could not find the schematic for it. I couldn't find a photo fact reference in the index. Nothing. It was a mystery. All American 5. But being an All American 5, you don't have to know that much. So as long as you can read capacitor values. So
yeah.
So I.
So what's an All American 5? Because that's going to be that's a question
what,
I don't even know.
That is what became beginning in the 1930s a standardized way of designing consumer broadcast radios, AM radios,
like
on the cheap.
5 tube or something?
Five
like
tubes.
That?
There's
Okay.
5 tubes. The filaments will always total around 117 volts. There was an All-American 4 that was even more cheap for the really cheapskate people out there. It was one that sold for next to nothing, and they usually deleted one of the IF amplifiers.
Oh, that's
So it was a
noisy.
weaker receiving radio.
Yeah.
But and the tube complements, depending on the era, are the same no matter the brand almost always. There's like a 35W4 tube and a bunch of others. So most of these radios would have identical tube lineups regardless of manufacturer. I've not worked with older radios very often that have like Lochtel tubes or the larger tubes from the 30s and 40s. I do have some that are AA5. But the Westinghouse we did on the channel, as well as this Philco that we're about to show you here, used the miniature tubes that were primarily used after World War II, especially in television sets. They use 7-pin miniature tubes, and the lineup almost always is a converter, 12BE6. The IF amplifier is 12BA6 usually. And the detector and first audio amplifier is 12AV6. Audio output is the 50C5. That's a 50-volt filament. That is, on almost all these American 5s, there'll be one spot on the top of the radio that either has a heat crack if it's plastic, if the radio has a lot of hours on it. And regardless of the crack or not, when it's running, that is hot to the touch, even if it's plastic, because that thing generates some heat.
Oh, yeah.
And then you'll have a 35W4 rectifier. So, and that is pretty much it. There are some variations on that, but, you know, the quick way to spot that is no transformer. They're usually switched on the neutral, which is terrifying, but just how it always was so often. Most people would, and these, especially Underwriter's laboratory changes of the day, required isolated chassis by 1960 or
Guessing
so.
you didn't want to just go poking around in
but
one
in the
of those.
50s, that wasn't as common as you'd expect. You'd still have exposed screws on the bottom. And so it was, you know,
a bit of a
don't touch
shocker.
it. They usually had a capacitor, I think it was, across the poles that would try to eat that and would get it to where it would
Try.
float them. Yeah. No,
Or it wouldn't kill you as much.
I've touched these screws and you get a little bite. You don't usually get a full 117 volts unless that cap's bad. It's a danger. But a lot of times
Goodness gracious.
a lot of times you're supposed to rewire those to switch on the other
You
one.
see,
and you're
that's
always
one
supposed-
way of keeping little Timmy from monkeying with stuff.
Don't put the screwdriver in the radio. I always wonder why the generations ahead of me were so nervous about me touching electronics, even in the 80s. Because like my grandparents were, and they was, that'll shock you.
That'll kill you.
And then,
That'll kill you dead.
You know, 5-volt DC logic stuff.
You could
but,
literally just touch it with wet hands and you're
yes,
fine.
it's not going to do anything. But that wasn't the case with the All-American 5.
No, that thing I've seen. Well, so we've looked at one of those. I guess I didn't realize we looked.
We've
at
looked at two.
And I looked at one of those and went,
I
looked at one of those and went, that is such a bad design. Oh my god,
However,
it's terrifying for safety.
Wildly common for 30 or 40 years.
Well, but it was safety wasn't really a concern.
No, and it was
because it was well, you know, it
These
wasn't.
Another fun fact about these being transformerless, every one of them could operate on AC or DC.
No kidding.
Yeah,
They could be, and usually you could run them on a, sub 40 volt power supplies or something, batteries back in the 30s and 40s. I'm probably got those voltages way out there. Sorry.
Well, I mean, if it's, you really just need to get 120, which is the RMS voltage.
But you usually
to
have to. They usually run as low as 40 volts. I don't remember what
honestly
that was.
probably would, because as long as there's enough heat to get that,
not as sensitive.
Yeah, so. If as long as you get enough heat to get the emissions working, that's really what you had to have. So,
anyway,
yeah, neat.
This is an AA5, and it was pretty rough, as you're going to see. There were blowed up parts. The case was cracked and it was dirty. I don't know how it got to me, but I'm pretty sure it lived a small time outdoors. So
Timmy found it in the woods.
It may have been. It had sat in my shed for 15 years, so even then I never even looked at it. So we brought another one back to life, and I'm going to show you how now. I've come up with this Philco twin speaker from sometime in the 1960s. This has been in my shed for years. I think my dad gave it to me. He got it at an auction or something. It's pretty rough. And I've plugged it in once years ago, and I'm pretty sure it had bad ripple filter caps, like is so common, like we did on the Westinghouse repair. So it's a model, it says number no F-226, and with a little looking around, I believe that is the model number. Again, I'm not sure what year it is. It's after Philco was purchased by the Ford Motor Company, so that'll help us determine a year. It's got a partial tube diagram on the bottom. I've been looking around and already found a similar radio with the same chassis, I think, so I'm gonna pop this open and see what parts are here, maybe get a true chassis number, and see if we can come up with schematics. Okay, to get in this model, you remove these 3 screws, it looks like, and there was a screw here and a screw here. A screw over here and here. And it looks like the front may pull out of this one. Yeah. I'm not sure if the knobs need to come off or not. I would have figured that would have just dropped right out of there. But what do I know? Back in a moment. Okay, I like to never got this loose, plus the cabinet on this is cracked down one side, but it does indeed come out the front. Like that. I think the power cord itself was getting stuck. Now, kind of a little compact All-American 5 we got going here, it looks like. It looks pretty straightforward. We got a pair of stock speakers, looks like. That one's stamped Philco on the left side. Capacitors and a cap there. Pretty good quality. One of those all-in-one deals down in here. Kind of multi-component. This is a really simple model. Looks like really straightforward and simplistic. I'm not sure it's showing us what model it is. 27 10865-6. It's going to be a pretty straightforward repair. I'm at least going to determine what capacitor that I usually need here. Okay. 50 microfarad, 30 microfarad. I may even already have those. We'll have to look and see. It's got a General Electric tube here. Philco. I assume that's a Philco, looks like it is, yeah. I always wonder if you see a different brand tube if it's been replaced before. Totally possible. That's a Philco as well, tell by the text on it. Or maybe manufactured with a GE tube, I don't know. That's the 35W4, yeah. This ought to be a fun one. It's kind of funny, I mentioned this capacitor being pretty good quality. Well, you know, not so much, guys. Get in here with the flashlight. it is completely shorted at some point and blown its lead. Probably spectacularly. I'm sure that scared the tar out of Grandma if this was sitting in her kitchen, you know. So I'm going to test the continuity on this. It shouldn't have any capacitors. Normally you don't really have any, so make sure you guys can see the screen here. Yeah, I see the one there. We'll connect this guy up here. It's shorted completely. No resistance whatsoever. Usually you'd keep the one. If we look at this electrolytic here, shouldn't show anything. And it doesn't, as you see. It caught a little bit of the charge there, but it stays a one like it should. So that's what you want to see. You don't want to see that. You don't want to see continuity. That's crazy. So that thing's completely failed. We've picked up all the replacement capacitors we need from DigiKey. I had one of these 50 microfarad 150 volts that I had bought extra of when we did the Westinghouse dual speaker in the previous video about a year ago. You see that up in the corner here now. Then I decided I wanted to stick to the values the original radio had, especially since I cannot find a schematic for this or a Sam's PhotoFact folder or anything. The radio itself is a pretty typical All-American 5. So I decided to stick to the values. So I got a 30 microfarad 150, and those will both replace the filter cap can here. And then for this, we've got a 0.068 microfarad orange drop, as they call it, that we'll put in place of this. And it'll fit better anyway. It looks like they had this one turned up on end and mounted really low so it would fit, and this will fit a lot better, this other guy. So so I think the way we're going to proceed is we don't know what this story is here. We can assume it's just a cap that's blown, but I want to do some testing on the tubes. We'll make sure all the tubes are okay. Some general cleanup, try to get some contact cleaner and an old toothbrush, and because these are really green and corroded. In fact, so is the ferrite bar AM antenna, which is a nice feature to see in a tube radio. You usually have them in the back windings and stuff. So I don't know exactly when this radio is from. It on the model sticker says Philco, a division of the Ford Motor Company, which means it's after, I think, 1961 or 62 when Ford bought Philco. And it's before the mid-60s point where they started branding everything Philco Ford with the blue oval logo after the Philco name. This does not have that on it. So we'll try to get it working electrically. We'll test the speakers with a sine wave generator, make sure they at least do something. I love how the wires are mounted. They kind of do the wrap thing on the posts here. That's the way a lot of Zeniths are built. So I assume this one's made in the USA. Actually, I think it may have said made in Japan on the back. Actually, no, I don't know. This speaker was made in Japan and this one's made in the USA. I thought it was interesting. Like the Westinghouse, it has the audio output transform mounted, riveted to a speaker. We need to get back to that Westinghouse. I've never got another speaker for it, and I was going to have to relocate this. So that radio's developed another issue too that we'll need to solve after restoration. I think it's got a tube that's shorting, filament to plate or plate screen to plate or something. It just goes all the time. Alright, so we'll get the test gear out and see what we can do next here. Okay, what we've got going here, I've got a sine wave generator hooked up to, or getting ready to hook it to the audio output transformer's output just to see if both our speakers work. I don't know why it's pulsing, that's odd. But this will help us answer the question. And it seems that both speakers have output, so it may be pulsing because it's in circuit. Now we've tested the speakers. We'll look at the tubes. This is a typical mid to late era All-American 5, meaning it's transformerless. You should really hook this into an isolation transformer when you plug it into power, which we will do. So your tube complement in this radio, and this is based on the tag on the bottom. I've removed the tags because we're going to look at restoring the case later in the video, so we're going to be cleaning that up. Looks like we have a 35W4 rectifier tube. Should be a 50C5 output. And a 12AV6 second detector and first audio amp, I think. What will you be? A 12BA6 IF amp? Yep, that makes sense. And a 12BE6 mix for the mixer and such. So what I'm going to do is I'm going to take these one by one and run them through my Syncor tube tester, and we'll just get a general idea if they're okay. I suspect they are, because I'm really thinking this just shorted out in blue. So I think our end game initially, other than just general cleanup, will be to replace this capacitor deal. I know you guys are always on me for, you say you should put these inside of the, your replacements inside. I am going to try to mount these more pleasantly than they were in the Westinghouse, but I'm not putting them in this. Can't even see in the back of this radio anyway. Okay, we'll start out testing the rectifier tube in this radio. It's a 35W4. So I'm looking in my book here, the settings that it needs to be. So you can bet it's 35 is the filament voltage, so you can almost deduce that for the filament. So it's set to 30, between 30 and 38. And B, the load should be A according to the book. Setup should be 7. C, and D setup should be 4. Or E, I mean, excuse me. It's tube socket 4. So, according to the instructions, we set the function control to calibrate. See, it's got a calibrate knob here. And we set it to the calibrate line on the meter. We see it is swept up there. So we'll get the calibration line dead on from above. Probably looks a little different on camera. That's pretty close. So we set it and we've calibrated. So we set the function switch to emission. And it says to read the top half of the meter. Emission quality. Showing good there. Very good. Next it says grid leakage. Use a lower scale. It's way over into good on the bottom. That's what we want to see. Short test. Set function switch to short test. Rotate switch D through all positions. Okay. A. And on this light down here will light if there are any shorts. Okay, this tube looks good. Next, let's check the 50C5. Kind of hard to see there. Is one of the original tubes from the radio. The first one, the rectifier, was a General Electric tube that I suspect was replaced at some point. Alright, let's do the same bit with it. Set it up, turn it on, calibrate it. This 50 volt tube is the highest voltage tube in the radio. All American 5s being transformerless. Basically the sum of the tube voltages will equal around 110, 120 volts. The line voltage AC in the United States. Check emission. And let's double check that calibration. Make sure it's good and warm. I think we're good though. These warm up pretty quickly. Emission shows bad. That's interesting. Okay. It may still work. If not, I'll have to dig one up. Let's look at grid leak. Grid leak's okay. It's poor emission. Let's do the short test. No shorts. Kind of want to let it sit on that emission for a while. Well, this tube's weak, but I think it'll probably still go. Alright, next up we have a 12AV6, I believe. Yes, that is the second detector and first audio amp in this thing. Get this guy calibrated here once it warms up. Let's sit for just a moment, see where it peaks. Okay, just below the calibration line. Okay, emissions. Good emissions here. Grid leak. Also good. Short test. Never got the short light. Of course, to be honest, I don't know if the short bulb works. Right, next we got a, what is this guy? That's the 12BA6. It's the 12BA6, which in this and many other AA5s serve as the IF amplifier tube. So I'm sure he's socket 4 as well on this tester. It's 12BA6. Okay, emission check. Good. Grid leak. A little more leaky than the others, but still in the good range. Ooh. Kind of interesting. You touch around the tube and it changes. Grid leak could be fishy on this. Oh, what's happening? Oh, there it went backward. That's weird. I wonder what that means. This has been stored in basically outdoor weather conditions, this radio, for a long time. More than 10 years. Don't know if that would affect all this or not, but no, let's check for shorts. No, see, now I need to recal. So the cal meter pegged, I didn't like that. Let's look at grid leak now. Kind of on the edge there, isn't it? Okay, let's check for shorts. No shorts. Okay. Okay, last but not least, we have a 12BE6. It's the IF, or the mixer and oscillator tube, not the IF. So let's get him in socket 4. Calibrate that. Emission good. No, leaky. I don't know what that brings to the table. We'll see what happens. Emission's good, grid leakage bad. We may go through our tubes and see what we've got. To be honest, I've not tested the tubes in these other radios I've restored, so they could all be crap too, but each radio does actually work. Oh, look at that. I didn't do anything. The grid leakage is just flopping all over the place. Hello. It makes whenever I tap it. Okay. Do the grid or the shorts. No shorts. Okay, we'll get into removing some components here. We'll remove the package capacitor, that's the ripple filter capacitor, and this cap here. And I'm not going to show the desoldering. You can go back and watch the Westinghouse video if you'd like to see some of that. It's not terribly interesting. And we'll be back here as soon as those are off. Okay guys, we have pulled the caps out. As you can see here, this is where the package was. It's marked A, B, and C, with A being the common on the very bottom. It's kind of hard to see. And you can kind of see them there in the shot. So that's how we'll line up what goes where with our electrolytics for the ripple filter. We pulled out the remains of this big dog. Look at that, that's nasty. It really blew up and really shorted out. The traces look good, it's a little dirty. I'm going to try to clean it up with a little contact cleaner here. So go ahead and just shoot on there and scrub it down probably. With a toothbrush I've got lying around here. Where that went. Yeah, it made a big difference already. There's a lot of green on this power feed here. Did a little cleanup here, about the best it's going to get probably. So now we need to figure out what goes where with our ripple cap here, ripple filter capacitors. So lead B was 50 microfarad, 150, and C was 30 microfarad, 150, and they'll both use a common negative. So this is the common, and it was mounted like so. So both of our capacitors we're putting in will have to, electrolytics will have to ground to here, and then we'll trace A and B based on the old package. I was hoping to do both of these vertically just to make it look better, but the 50 microfarad is too tall. Its lead isn't long enough to get to the common on the right there, right here. So it's leading over. I did get the 30 to sit nice and flat on the positive side, so we will make this work. While I'm waiting on my soldering iron to heat up, I thought I would go ahead and test one of these film capacitors. It's supposed to be 0.068 microfarad with the Heathkit IT2250 I've had for a while. I'm sure they'll be fine. I'm just kind of curious. I'll say that should come up 0, and let's put this guy in here. I think the contacts on this need a clean. There you go, 69 nanofarad. That translates to 0.068 microfarad when you move the decimal. So that'll do. Okay, we've got our caps tapped or soldered in there. Our ripple filter, our new ripple filter. So I wouldn't call it a work of art, but it's going to do the job. Okay, now let's get our 68 microfarad capacitor situated here. These are always tricky. I don't remember exactly what the purpose of this one is. Kind of to bias the, or to lift the B plus a little bit so it doesn't shock you or something like that. I don't know. Who knows? So basically we're going to take it through the 2 holes that the prior one that blew up was in. Make sure to not get too close to the power feed here. Just like you saw me do at the Westinghouse in that video. Let's just put it right there. Let me get you in here to see it. There we go. Now you kind of get the idea is you want to make sure you're not touching that because it's pretty tight. It's not touching. It's kind of hard to tell from your camera angle, I'm sure. There we go. You just want to carefully put that in there. Just make sure there's no, interconnectivity between the AC line in and that. Actually, that's okay if they would touch. It wouldn't hurt anything really because they're on the same trace. So that basically connects across the AC line. That capacitor. Also why when it shorts it blows up spectacularly because you're feeding 120 volts AC. There we go. At this point I want to double check everything, make sure we didn't make any mistakes. Make sure that our polarity is right on the electrolytics especially. Double check that with the original. A, COM negative. That is for sure pin A, the one that's spaced out further. Mounted like that. Foil side of the electrolytics both go to that hole. Check, check. This guy here's looking good. Tell you what, I think it's time to fire it up, but first I need to go find my isolation transformer. Okay, what you see here is a RCA TV ISO-tap WP25A from the late 50s or early 60s. These are used in television and radio repair shops all the time, especially for transformerless things, such as the Philco here. This isolates the ground side of the B voltage, so you can't be ground back and actually be shocked by a voltage. It's the short answer. Got that connected to the Variac that you've seen in a previous episode. Did a whole episode on repairing this. Had to put a new cord on it because the original was rotted away. I think I may have a photo of that, but somehow we've lost the footage for the first time that we can think of in 3OTD history. So hopefully that'll turn out. That would be a pretty good video, but meantime, here it is. So that's a safety item we want. So we'll plug the radio into this on the isolated side and Variac it up. I'm using a kilowatt P3. I may take that out first. I wanted to make sure that we're only drawing what I believe the radio is rated for, 35 watts, something like that, as we power up. So let me check on that. Okay, we've got the ISO-tap set to line voltage, which I've got set to right around 110 on the Variac. So initially, tell you what we're going to do. I don't think it'll kill the kilowatt. I'm going to turn this down. I'll set this to watts. So this thing goes inaccurate when it goes low voltage, which, makes sense. I'll turn it down there and we're going to turn this on. Let the tubes start going on it. They should anyway. Turn the Variac up to about 60 volts. No smoke yet, that's good. Pulling 37 watts, about 10 of which are the ISO-tap. It pulls some watts on its own. Trying to get static out of the speakers. Actually, it sounds right. Sounds good. Let's see what we get a station here.
We have great news.
Look at that.
End the painful finger sticks with a new CGM. Plus, they may be covered by Medicare, Medicaid, or private insurance.
Alright, I think I feel safe going up to full voltage now.
You may qualify. Call US Med now to learn more. 800-426-0557. 800-426-0557. 800-426-0557. That's 800-426-0557.
Right at 35 watts.
Hi, this is Chuck.
Little extra with this again.
Your local dealer for Steel Power
35 watt radio.
Steel is the #1 selling brand of handheld power equipment in the United States. Our trained crew is here to help you choose the right equipment, show you how to use it, and keep it operating for years to come with our parts and service department. At Superior Small Engines, located on Main Street at the Light in Mitchell.
Sounds pretty good.
Superior Small Engines. Get equipped.
Stop in Michael Signs today and learn how they can make your sign needs a vivid reality. Whether it's business or personal, Michael Signs can create full-color indoor and outdoor signs, banners, yard signs, magnetics, and let's not forget vehicle wrap and lettering. Michael Signs is determined to complete your projects to your satisfaction on time and within your budget. Visit the sign shop on the corner of and Drive in Bedford or call them at 277-0000. That's 277-0000.
WBIW Weather.
Your local weather is brought to you by Airmaster Heating and Air. Don't let the cold in with a broken down furnace. Airmaster is available 24/7 to keep you and your family
speaker's
warm.
actually blown.
It's free. Radio.
Must be a dirty volume
Radio's
bottom.
all you need. Radio's all you need. Radio's all you need. Radio's all you need.
It's radio. Here we go. So how do you like it?
Okay, this speaker sounds like the cone's ripped or something's in it. This one sounds really good, so either going to have to bypass this speaker or replace it because it sounds so bad that the radio is nearly unlistenable. This side sounds great, so I know it's not the electronics. Okay, I've tried to take this speaker off because I wanted to see if the cone was ripped or something could be repaired, and it's got these little rubber deals over the plastic, and boy, they're sure hard. They won't move. I'm kind of afraid to mess with it. So this radio is just a radio that was found and probably saved from the dump. I'm going to bypass this speaker that has the audio output transformer on it by connecting it. I'll make some modification here to where it could be reconnected later, and just connect the left speaker because it sounds pretty good, but not when the speaker's in play. So may re-examine that down the road, but to make it listenable, that's what we're going to do. Okay, got a little bit of work with the screwdriver here because I kept pushing on this cone and I thought it sounds like there's something in it. So I decided to work at the rubber grommets with a screwdriver and managed to get them loose, and I can't tell what in the world is in there. Or if it's just the paper failing or what, but I'm going to try to back it out more and get a closer look. So this speaker's intact, but it may have gotten wet or something because it's, yeah, that's like paper brittle right there. So that's what's making the terrible noise. Parts of the cone are okay. So I may look into replacing this. For now, I may go ahead and temporarily do the bypass just so I can clean it up and use it for a while. I probably will circle back to it probably when I do the Westinghouse, which also needs a speaker still. Okay, ended up cutting the transformer lines off the audio transformer that went to this terminal block that was doubling up on the speaker for the speaker itself, and the two lines that would go to the left speaker. I just tacked them down with a little bit of solder and just to try to position them in there. These lines were floating to that terminal block anyway, so it's not going to touch the chassis or anything. So we'll get that down in there and see what we can do with it, and that's a good temporary fix to at least make the radio usable until we deal with this dead speaker, which, just like the Westinghouse, is going to involve figuring out what to do with the audio transformer. There's a solution on the Westinghouse to mount it to the chassis. There is no such thing in this radio. It's also tight.
There are issues with no doubt. Tampa Bay's offensive line's fabulous. Their center, Ryan Jensen, finished the game, should play. Tristan Wirf's the right tackle. Marion play. They're working on him. It's tough to ankle. Their right tackle, especially, his kick leg, his plant leg, his right leg.
Sounded pretty good.
Maybe he plays.
Now we do something about the power cord and the cabinet. Okay, so it's been a few weeks since the last clips were shot of this radio. We got the basic repair working with the capacitors and gave it a little test run. Of course, I want to be rid of this very, very rough power cord. As you can see, we can't reuse that. I've looked into replacing these. You know, there's some tricks you can do, but really this is a pretty, you know, basic radio. It really doesn't have a lot of value. Some people may argue that, but it doesn't. It's a typical AA5 tube radio. A lot of them still out there in the world. So I went to Lowe's and bought some lamp cord. Simple, affordable stuff. And I looked around until I found a polarized lamp plug, basically. It's a pretty low power radio, 35 watts I believe. This can handle up to 1250. I'm not sure I would advise that, but it can do it. So I'm gonna clean these up a hair and probably just solder right to them as we did with the Westinghouse radio in that video. Getting ready to hook up the stuff to see which way I want to wire this power cord. I'm making the assumption, due to lack of a schematic, that this is switched on the neutral line, so I want to make sure I get the polarization correct on this. So I'll study a little bit. I put a couple little dots of good old Elmer's school glue on these. Why'd I use that? Well, I'm probably going to want to pop these off in the future, and that should allow me to pop those loose with a pair of pliers. They're just rubber grommets, but they've gotten hard. You know, I think they originally slipped over that, but once they came off, they weren't really ready to go back on very well. And this radio is either going to get a new speaker, or I'm going to learn how to recone this one, since we know the resistance and everything is proper on it. So maybe a future project for the channel would be a good radio for testing that on. Got my diode check, I think is what it is set, but anyway, it'll give me a tone. If I've got this right, I think this should be the neutral side of this. I'll turn on the power and we should get a tone. Yep. We've got the other side of this grounded to the tuning slug there. Okay. So I previously took some Gorilla Glue, glued this big crack back together. It was pretty bad. It's been sitting for a couple weeks. Then I labeled what I've got. Most of the labels were with this, and we're going to glue them back on probably after the video. But I wanted to write down some information inside, so for anybody that finds this in the future, because this radio eventually is going to move on. So maybe to one of you viewers. So I'm going to run this through here initially, our power cord, so that I can get it attached here. I'm going to get a good knot in it so that it doesn't pop through, maybe a couple, because I don't have a grommet that size. I have some round grommets, but none of them would fit that hole right, so we'll see what we can do here. Basically, I'm going to bend these up with a pair of needle nose pliers gently so that they're up more, so that this isn't sticking out the back of the radio. That's what we don't want. This has a Underwriters Laboratories required floating chassis for the era. See, it's up on the plastic here on these notches, so it slides in. You shouldn't be able to touch any electrical part of this, basically. So it's got recessed screws and everything, except on the front here. But those are actually separate of the chassis too, or the electrical, you know. So I've got the power cord soldered on. This isn't the prettiest thing ever, but it has great mechanical and electrical connectivity there. To accomplish that, I ended up using the Weller 8200 just for the sheer heat and being able to heat the pins up enough to where it would take the solder. I don't usually like using that much heat, but the little old Radio Shack 25 water wasn't going to cut it. I've got the pins bent upward. Make sure that's going to touch, that there's enough space between both of them. And I think we're ready to get the knot tied and button it up. Looks like our glue's starting to dry up here. It's what we want to see. Alright. Okay, tied a couple of big knots in the cord so as to keep it from flying out the hole there and to give a little relief of tension on the power pins there. Okay, we're back together now. I still don't have the plug on the end of our cord. We'll get that in a moment. Compared to how this looked at first, it's a lot better. This has been washed basically like we wash dishes. It's about as clean as one could expect. It's certainly better looking than it was to start with. Couldn't do much with these grates, but I did manage to clean around, you know, about as best as it can be for a radio that was basically literally safe from the garbage. Got the screws in the bottom, don't have my labels on yet. You might recall, if you were paying attention, all the screws were black in this. I lost a couple, so I found some machine screws that fit were the right thread angle and all that stuff, and got that in there. And same with the back. I did lose one of the back ones and when I lost the others, but two of the originals are there on the sides, and then another silver machine screw in the middle. So let's get this plug on and give it a test run here once again. Oh, I should show you this too. See the knot here, kind of hard to see, is keeping the tension off of those plugs and keeping fingers out of there, so that's good enough. Okay, got my plug on the way I want, good and solid. It's a typical clamp on lamp plug, so I'm just careful to make sure I knew which wire went to the polarized side and vice versa and stuff, and we're good to go. Let's give it a test flight.
Who was president in 2014 again? Oh, that's right. Interesting. We'll get into this in a moment, but Trump is the Russian agent, they say, and they were real quiet for about 4 years.
Noisy on the receive, but might be the lighting I'm using in here.
Would be a false flag.
Here we've got it on. I've got my Vectronics 1290 AM transmitter kit going here. We'll try a Three Old Tech Dudes video over this thing.
Oh.
Which one?
I'm Timmy. I'm Justin. I'm Nathan. And this is Three Old Tech Dudes. Kid tested, but not mother approved. How's things been going, boys? Not bad. Been having a good week?
Huh.
Okay.
Doesn't sound too bad that way.
You? You act like you weren't prepared for that line of questioning.
Really playing music over these with a transmitter is your best bet to enjoy them anyway.
Died this week, and I gotta get there.
So that's the Philco F-226, early to mid 1960s dual speaker radio. Down to one speaker for now, but we will figure out something for that in a future video. I think his is an 85. I don't know, is that shortwave of it?
Yes.
It may not be then. It's probably something fancier. It would have cost more new too. So.
It has shortwave and polies,
Fancy. So.
Popo channel.
which is kind of odd for the 30s, isn't it?
Yeah, but it was a thing.
Yes, no, it wasn't. They weren't quite using the same frequency as they are now. But
well, no, they had the big, Barney Fife antenna that went from the front bumper to the back bumper.
That's right.
It was basically in a 6 meter range, I think. But
Yeah, 40 megahertz around in there. All right. Well, tell you what, guys, I think it's time for Echoes from the Asylum.
Well,
Well,
we do look at these, by the way.
Sometimes in real time. Oh, here's one from our buddy Dan Evans.
Hey, Dan. Yeah.
K9ZF. Dan interacts with us a lot, so Dan gets a lot of attention. We appreciate you, Dan. Thanks for getting in there.
You could be another Dan if you just write down there below.
Change his name. He writes on the Commercial Trades Institute TC10 tube tester video.
Oh, yeah.
Another item from the old N9 CMM collection. He writes, great job, guys. Keep up the good work. I've been an old radio nut for a long time. Speaking my language. I spent a lot of time watching Shango, Radio Rescue, and Mr. Carlson, all YouTube channels I've watched. So
Yeah.
I think Shango is my favorite of those. He's a different feller. And he's redoing tube radios in the middle of Los Angeles. How about that?
Hey.
So I've been slowly building up a repair bench of my own, Dan writes. Found a good buy on a Variac at the Cave City Hamfest.
Nice,
Excellent.
Nice.
Get that bench going.
Very nice.
Still need to find an isolation transformer and a tube tester.
Tube testers
I
are
could
hard to
hook
find.
you up.
Yeah.
Dan finishes his comment with this. Keep doing restorations, building antennas, and you should gather some followers. Probably.
We hope so.
Yeah.
And then he writes, here's something for you. Say, I will message you sometime with some more ideas to help add subscribers.
There you go.
73K9ZF. Hey, I tell you what, Dan. If you start rebuilding radios, make some video clips, and we'll put you right on the channel if you want.
Heck yeah.
So, and anyone else out there that's got some cool projects. So we'll
Thanks
work
for
in there. We'll do a viewer content section
There
or
we go.
segment or something occasionally. So that could be fun.
Dude, welcome to the waves.
That part of each 3 Old Tech Dudes episode where we welcome a new amateur radio operator to the hobby of ham radio. This episode, we welcome Daniel Thompson, KE8URG of Columbus, Ohio, to the hobby of ham radio. He's a new technician. Thanks for joining the hobby, Daniel, and we hope you enjoy it very much. Anyway, thanks for watching, everybody. Be sure to subscribe, like this video, leave a comment. That really helps algorithm a lot.
Yep. Find us on that there Facem books.
And Twitter.
And Twitter.
And you can email us at thedudes@3oldtechdudes.com. Woo! Well, I'll tell you what, we'll see you next episode. Until next time, I'm Timmy.
I'm Justin.
And I'm Nathan.
And this is 3 Old Tech Dudes. Thanks for hanging out with us here on 3 Old Tech Dudes. Please subscribe to us here on YouTube for more tech old and new, tinkering at the workbench, repairs, ham radio, electronics, computers, and more. Please like this video and share 3OTD with your friends to help us grow the channel. We tweet at 3 Old Tech Dudes 1 on Twitter, and you can keep up with us on Facebook. Just search for 3OTD and look for our logo. Thanks so much for watching.